Right before we begin this video, I'll just say that I'm very sorry about the camera quality in most of the video. That is mostly because I'm filming, right now I'm just filming on a webcam on my computer because I don't have my camera stuff set up. And in the rest of the video I'm using a outdoor camera in a quite dimly lit area. So the quality will improve in future videos, but this one, just bear with me. In this video I'll document the adventures I've been to decide make my small little DRSSTC. Okay, so my first try was a really big mess. I just took the capacitors that was already on my store-bought Zvs driver and just plugged them in series instead of parallel and just started tuning. And you can see my scope in the right hand side, and it didn't really work as I planned. So my problem was heat. My MOSFETs were getting really hot, and that isn't really good for the FETs. So to understand why they were getting really hot, you must understand how a Tesla coil and a Zvs driver work. Oh, alright, I stole this from Zvs Driver DRSSTC, and it's not the exact thing I use, but it is very close. The way it works is that you have these two MOSFETs sending pulses of energy into the inductor and capacitor combination. They form a resonance circuit, and when you have the two coils at resonance, it boosts the voltage and you get maximum energy transfer. And the reason why my MOSFET was heating up was because my coils weren't close enough to resonance, so I still had a lot of the power in my Zvs driver. And you don't really want that, because then your MOSFET is going to heat up and the more power fall across your components. You want that power into the plasma. So the way I solved it was just to make them resonate closer to the exact resonance frequency, and it was perfect. Well, not really. As you can see in that clip right here, I did get some pretty good results, but those socks were not as powerful as I really wanted. And you can also see I used way too small capacitors. Those heated up a lot, and I needed to use fans in the MOSFET, and the output power overall wasn't even that high. I didn't even get burns, so I needed to fix that. I need to fix that very much. And I also just tried to put in some bigger capacitors, but those capacitors were really cheap, and they didn't really work as they should. So I needed to come up with a better plan. So yeah, it's been quite some time. So now I can run the coil at 24 volts at 8 amps without that much heat being generated in the MOSFET. But now the problem is the capacitor leads heating up. So I have some better caps which I can put on it for the next video. And these box also got a lot more powerful, but I have some better plans, so look out for that video. So I know this video has been kind of a mess. I recorded it over several weeks and all that stuff, but I hope you still enjoyed the video. This is definitely a pretty cool coil, and I will improve it a lot in the future. In fact, I'm gonna go down and work a bit on it now, and I hope you'll look out for the video where I show off the final coil. This part of the video was not originally planned, but now I'm making it, so yeah. I don't recommend you build this coil if you don't have a lot of experience with high voltage and Tesla coils and resonance circuits in generally. I have been working on Tesla coils for almost 2 years now, and this was still a very hard project for me to do. So it is very hard to get the thermals right, it's hard to get the performance right, and you're just gonna waste a lot of money if you don't know what you're doing. So yeah, remember, be safe and don't electrocute yourself so you don't die.